Hi guys, my name is Pearl, and today we're going to be solving this question. So it says, given the mixer and the traffic light, there are three outputs for the mixer: pump, valve, and motor. We're going to refer to them as Q0, Q1, and Q2. Now there are two inputs, I0 and I1, for start and stop. Now, whenever you want to design a PLC, the start signal always will be a normally open signal input. And for a stop signal, it will always be a normally closed input. You're going to see this throughout the design of this particular question, so take note of this. Now, when IO is pressed, pump Q0 should come on for 10 seconds. After 10 seconds, Q0 should go off, and the valve Q1 should come on 5 seconds. After 5 seconds, Q1 should go off, and the motor Q2 should get on for 7 seconds. The same sequence is applicable on the traffic light too. So basically just saying that you can also use the same system you're going to design for a traffic light system. So let's get to actually designing this system. I'm going to use these steps. So basically when IO is turned on, now note that IO is a push button. Let me try it out here. IO is a push button, which means let's say the output here is Q, which means when you turn on IO, it will begin to conduct. But then once you turn it off, you release the push button, Q is going to go off, and that's not what we want. We want Q to remain on for 10 seconds. So we're going to add a memory bit that will remember the value of what I naught was before. Simply going to be in parallel with it. We name it M0. Now when you turn on I naught, it will begin to conduct, and so will this. The electricity is going to be coming to this area. However, when you release the push button, MO will still continue to conduct, ensuring that Q naught is still on. So in this case, I'm just going to segment it. The output in this case will be MO, and this MO will be what will power the output coil. Now, I forgot the I1, which is the stop signal, should also be included in the diagram, in the beginning of the diagram. Remember, it's a stop signal, so to be drawn as a normally closed entity. Going to be for MO. So this output MO is also going to drive the timer. So we want that as long as MO is on, this timer should begin. So we're going to use an on delay timer. For an on delay timer, this is EN, this is the accumulator, this is the preset signal, this is the output. When MO is energized as it is now, it's going to enable this timer. Let's call it T1. So this T1, we're going to give it a preset value, which is 10 seconds. We want Q naught to be on for 10 seconds. So we're going to give it a preset value of 10 seconds. When MO is on, it will begin to count 1, 2, 3, down to 10. Once it reaches 10, we want it to chicken should shut up. We want it to energize the next memory bit, M1. Now, this M1, we have to find a way to make sure that M1 turns off Q0 and turns on Q1. Now, like I said, if you want to turn off something, that's a stop signal, we use a normally closed input. So I'm going to simply add M1 here as a normally closed input. So once M1 here gets energized, it will have a value of 1. You agree with me? So at this point, it's going to have a value of 1. If a normally closed contact becomes energized, guess what? It stops conducting. It goes from a normally closed to a normally open contact, meaning Q0 will no longer get energy to itself. So now the next question is, how will we make sure that M1 turns on Q1? This way it gets a bit tricky, so you have to really focus on this one. So I'm going to design M1 here as a start signal because we want it to start Q1 here. So M1 is going to act as a start signal here for Q1. Now you might be wondering, how can M1 be a normally closed contact here and it's a normally open contact here? You see, a memory bit saves temporary signals. It doesn't save the contact type. It just saves a signal 1 or 0. In this case, you can see it has saved that the signal here is 1. The signal here will still be 1. The signal here will still be 1. But based on whatever the contact type is there, that is how the behavior of that circuit will be. So for instance, now here is a normally closed circuit. If it becomes 1, it disconnects, causing Q0 to turn off. Here's a normally open. If it becomes energized, it will power on Q1. So memory bit it stores signal, it doesn't store the contact type. So keep that in mind. We want Q1 to remain on for 5 seconds. So we're going to connect M1, the input that is now active, the memory bit that is now active, to a timer. I'm going to connect M1 to a timer, an on delay timer. This is the enable bit, this is the done bit, this is the accumulator that counts, and this is the preset value. The output is going to be M2 because that's the next memory bit we're going to use to control the circuit. So now when M1 is energized, we need a preset value of, we want Q1 to be on for about 5 seconds. So when M1 becomes energized here, timer is going to start counting 1, 2, 3, all the way to 5. You understand that part? When it comes 5, it's going to energize M2. Now we want M2 to turn off Q1, which means again we're going to design M2 as a normally closed signal. So at this point here, I'm going to add M2 as a normally closed signal. So when M2 is not energized, that means the timer has not gone off. At this point, the timer 2 has not gone off. It's going to be conducting electricity like normal. However, when M2 now becomes energized, it has the value of 1 now. It's going to turn from a normally closed contact to a normally open contact, effectively turning off the power to Q1. Now, next is, how can we design M2 to turn on Q2? Simply follow me, follow me. So it's going to be M2. We're going to design it, since it wants it to start Q2, we're going to design it as a normally open contact. So this is going to be M2 and this is going to be Q2. Now please note again, we have a value of 1 is energized, has a value of 1 here. It will still have a value of 1 here, and here will still be a value of 1 here. But because it's a normally open contact, when a normally open contact is energized, that's when it will actually start conducting, effectively turning on Q2. So we're gonna have this. Now for the last part, we want Q to remain on for 7 seconds. So we're going to put M2 into a timer. M2 is going to go into a timer that will remain on for, reset value is 7 seconds. Is the enable bit, Q and accumulator. So once M2, which is energized, enters into the timer starts counting. The timer, I'll call it T3 here. The output for the timer is M3. Now, once M3 gets energized, we want it to off the entire circuit. How do we do that? In order to off this entire circuit, we actually have to turn it off from the starting point. So what do we do? I forgot to mention this is I1. I didn't label it. In order to turn off the circuit from this point, when M1 is triggered, I'm just going to add it here to explain. We're going to add M3, so it's not M2. The output here is TM there. We're going to add M3 here as a normally closed switch. So normally it's conducting, it won't affect the circuit. But the second it gets energized here at this point, since it's a normally closed circuit, Once a normally closed circuit is energized, it goes from normally closed to normally open, effectively turning off MO. That means MO will never have energized Q not. MO will never turn the timer, started the timer for 10 seconds. You get to the whole circuit effectively turns off. So that's how to design the circuit. Now I sketched up a simulation on Open PLC I would like to show you. So I want to take a look at this simulation. I'm going to energize I naught, then I'm going to turn it off. Now you see it has energized Q0. M0 has also energized the timer. Once it reaches 10 seconds, it's going to energize this, which is going to disconnect the circuit and start the circuit. Q1 is now on and it has also started the timer. Once the timer elapsed, you see it has enabled M2. M2 has turned on Q2. M2 is now started the timer. Yes, once M3 became enabled, it disconnected the circuit at this point. I know this is a little bit fast, but you can replay the video and just see how the simulation works. But that is it essentially. So any questions you have, don't hesitate to ask them in the comment section. Thank you for listening.